This is going to be the last video on classes. So we're going to again develop a class, this time developing it from text. And then we're going to talk a little bit about static functions and static member data. So one of the problems in any class that you take in computer science, anywhere in the world or in programming, is that, and other classes have this problem as well, we tend to give the students problems that are pre-digested in some way. So the real world is not like that. The real world, you have to figure out how to create your own specifications from just a bunch of words. So here's an example of that. So in this case, let's say that this Captain Hook person sends you this message. They want to create a program to help him manage the boats in his boat storage yard. He needs to keep track of some basic information about each of the boats. Every boat has a name as well as a state ID number. Boats can either be sailboats or motorboats. It's important to keep track of the length of the boat because they usually charge based on length, the monthly cost. We also need to know how tall the boat is to make sure it's going to fit, and the beam, which is just the widest point of the boat. We also have to keep track of some billing information, who pays the bills. So the owner's name, along with their address and phone number, would also need to be tracked. Okay. So you can go through these and kind of pick out. So the boat is going to be the class we're doing. That's the object. And then we look at some of the attributes of it. Okay. So we need things such as its name. Okay. So you can kind of see as we go. You can need its state ID number, things like that. Okay. So we can use that to get started on this idea of a boat class. Okay. Pop up. I thought I had a boat class. Maybe I don't have a boat class. Maybe I was going to do it all live. We'll see if I've done this or not. Looks like I have not, which is okay. Yeah, it's fine. Okay. So let's go ahead and do our boat.cpp. Okay. And again, you can put some stuff in here. It's the boat class. It models boats for blah, 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 whatever you're going to put. The normal things we put. Okay. So we're going to have our class boat here. And I go ahead and put in this last one because I always forget that semicolon. Okay. So I always start looking at what are the private member data that we need to track. Okay. So in this case, we're going to have a string for the boat name. You can say boat name or just name, doesn't matter. You're going to have a string for the IDs that sometimes have dashes and letters and different things, depends on the state. A string for the type of boat. Is it going to be a sailboat or is it going to be a motorboat? And that's a place where an enumeration may come in handy, potentially. Okay. Let's have a double for the length. We're going to have a double for the height, a double for the beam. Okay. Then we need some more strings for the owner, the address. You can break this up into multiple fields, but we're going to keep it straightforward here and for the phone. Okay. And that should be the private data that you need. Okay. So we now have to think about the accessors and the mutators. Okay. And it's always a question whether you're going to have each of those. So let's look at the accessors. So are all of these things we want to be able to access from outside of our class? And I think the answer is yes. Okay. Mutators, you also have to ask a couple of questions. Does the data need to be changed? Should it be changed? If so, how can it be changed? And a more general question, what are valid values for the data? Okay. So let's take a look at doing an example here on what all of the accessors are going to look like. Okay, so let's do beam. Okay, so beam's a double. That's a return type. We're going to call it get beam. And these are always constants. Okay. These do nothing but return beam. Again, they can see inside the class, but since they're not, they need to be public. Since they're public, other functions in other programs, int main or whoever can get to them. That's the point there. Okay. And all of the other accessors look more or less like that. Okay. So again, the mutators, we have to think about some things. So let's think about height. So boat yards typically, or the roads going to the boat yard, will have some maximum height. Now, if you're used to motorboats, they're not very tall particularly, but sailboats can be very, very, very tall. Okay. So this is something you'd have to go back and talk to Captain Hook and say, so what can you accept? Okay. And let's say that he tells you that no boat is shorter than 3 feet, but they're kind of maxed out at 50 feet. Okay, so we're gonna have to check that. So when we're doing our mutator, we're gonna have to put those checks in. Okay, so we're gonna have to say they have to be no less than 3 and no greater than 50. Okay, so we're gonna enforce that in our mutator. Okay, so these are always void functions. They're a set height. They're not constant because we're changing it. Got a double H. I usually put the first letter of the attribute just to keep me straight here. So I'm going to say if H is greater than or equal to 3, or and, think about that. And I think these always confuse me. H is less than or equal to 50. Right. We want it in the middle of that range so we can do an and. Okay. Then we can set the height equal to H. And the else, I mean, you've got other options here. You can see out some kind of message that something's wrong. And you can also set the height equal to whatever the default is. Let's say it's 6. Again, that would be something that the customer, the Captain Hook, would have to determine. Okay. So that's going to get us what our mutators look like, and each one's different. Is there a maximum length of the boat? Probably. Okay. And a minimum. What about the beam? Assume that there's a maximum beam. So all of those things, you have to make sure that you know from the client what those are. As far as the type of boat, again, this would be a good example of an enumeration potentially, because you can only have sailboats and motorboats. So you want to in the set for type, make sure they pick up one of those things. Okay. So the other mutators would follow in a similar manner. Okay. Then it leaves us here of thinking about the constructor. So with the constructor, we have to think about what do we need to have a minimum object that makes any sense. Okay. So in this case, a blank boat with no data doesn't make any sense. Okay. This is again a question you'd have to discuss with the client, but I'm going to make the assumption that you can put a boat in to get the price, but you don't have to put the owner information in yet. And there could be some boats that are owned by Captain Hook himself. So you wouldn't put that in there. Okay. So we're just going to assume that our boat constructor is going to look, okay, like this. So remember the constructors have no return type. Okay. It's going to take a string N for the name, a string I for the ID, a string T for the type, a double. I'm doing length because L is difficult to see and distinguish from ones. A double height, a double for the beam. Okay. So that's all the information about the boat that I need. Okay. And then inside of the constructor, I can go ahead and put something in here that this is constructor, just so we know. So whatever restrictions on the data that we have enumerated in the mutator, we want to replace here or replicate here. So we can either copy it again, or we can just call those. Okay, so what I would do, I would have the constructor call set name, okay, on an N. And then I would have it call set ID on an I, okay, and so forth. And I would call the constructor for all of the ones here ending with a set beam. Okay. That way you don't have to put both, you don't have to put the restrictions in both places. Okay. Both in the mutator and in the constructor. Okay. That's a pretty common way to do that. Okay. And that ensures again that you have a boat that's the minimum possible boat for the system. So the book also talks about header files. So a header file is where you separate out basically what the book has been doing when they define the functions not in the class. So it's the class prototypes and the class member data. If you put all that in a separate file and call it a .h file, you then put the implementation or the actual functions in a separate file that you include the header file into. And oftentimes that .h file or the header file is what you would give someone that's going to be using your code. You don't want to give them your whole source code because you don't want them to be able to see all your secret sauce that you're using, but you have to give them something to document the class. So the header file is often a way to do that. Okay. And we're not going to go into it at this point. We may hit it later. We probably will almost certainly hit it in data structures. Okay. So that's where all that stuff comes from. When you're doing that, it's a good idea, and it's never a bad idea to, for each of your functions, give them a little bit more description than you normally would, assuming it's someone who's not going to see the rest of the code. You can also consider, we've talked about this for functions, putting in the preconditions and the postconditions. So what do we assume is happening when the function's called, and what is the state of the program as the function leaves? Okay. So those are always useful things to talk about. Okay. So the last thing we're going to talk about today is this idea of a static member data. Okay. Let's see if I have a static program here. Yep, I have static. So I thought I did. We've talked about static stuff before. Okay. So again, a static variable in terms of in a class. So if a class has a static member variable, okay, it's going to be a variable that belongs to the class, not to the instance of the class. Okay. So in the boat class we just did, the boat class is our abstract blueprint of a class. Okay. So if something like the get beam, you can't say boat.getBeam, right? You have to create a boat called B1, let's say, and then B1.getBeam. Okay. Where a static variable, you would call it on boat itself. Okay, it's part of the class. Okay. Oh, this is not the right one I was talking about. This one we talked about before with static variables. Okay. So I guess I didn't type that example either. You know, in the semester, people get weird. Okay. So let's do this illustrate. Actually, I may have I do. That's what I called it. That's what we're talking about here. Okay. So that's what I just said about things being they belong not to the instance of the class, but to the class itself. Okay. And we see this most often if you want to keep track of the count of all your objects, that count can't be attached to any of the instances. So you attach it to the class itself. So let's look at an example here. We have this class called illustrate. Okay. So I always like to start down with our private. We have an int x, some number, and we have a static int y. Okay. Which means that every object we create from Illustrate will have its own version of X. All the versions you could ever create of Illustrate have the exact same Y value. Okay. And they can't change it independently. So, I mean, in this case, it's kind of weird because you're treating numbers the same way. It's just trying to show you how it works. Okay. We also have, which is more common, a static int count. So this static int count belongs to the class you can put in the constructor every time that you create a new one that you're going to increase the counter by 1. Things like that. Okay. So this is just giving us some basic information here. We can set X. Okay. Every object has its own version of X, so they can set X independently. Okay. The Y is different. So the Y they're determining just needs an increment. Okay. So y equals y plus 1. Again, that's for all classes have the same y value. If I call increment y in one instance, it's going to make it all the y's for all the objects will have that same value. Okay. Um, and then it just goes through, does a few things here with the constructor and things like that. Um, so the increment y has to be a static function because you have to be able to say illustrator dot increment y, not any object. Okay. So that's kind of how those work. And again, it's in the constructor where you would normally add one to the count. Okay. So we often think of the word static as in not changing. And that's not really what static means in this case. In this case, static means, again, that it's a variable or a function that you call with the name of the class, and it belongs to the class and has the same value for all members of that class. Okay. So that's kind of what that does. Okay. So I think that's it for class. There's a lot to classes for sure. And some of the assignments we've done are fairly complicated. Um, and this is again, as I said in class, this is a preview of where we're heading with data structures. Okay. We have to have the ability to think through bit by bit, piece by piece, how to construct these things. And you always start with the class definition itself. And sometimes you have to modify it as you're going along, but get that base first, get it working with the test program, and then move it into your application. As always, if you have questions, make sure you let me know.